Okay, it's chapter review of the material in section 2.8 and also chapter 3, excluding section 5. So we're going to go to that. Some of the problems will be the same ones that I went over in class. Some of them will not. A couple of the problems that I went over in class will actually be on your exam 3 test, the same exact problem. So with that, let's get started and go to the review pages. So here we go. We're starting with section 2.8. Okay, the rules for operations. If you're adding two equations, you just simply add x's with x's, x squares with x squares, and so on. Same thing if you're subtracting them, multiplying them, which would be distribution and division, either canceling or possibly you could use synthetic or long division if you needed to. Some examples of this operation. Okay, if we have the first equation is x squared minus 3x plus 1. The second one is square root of 8 minus x. The third one is 2 over x plus 1. Then it asks us to evaluate. When it gives us a replacement value in the equation, then we want to do that first. So if we just find the value of f of -3, we replace the x squared, the x with -3 in each location and evaluate it. If they replace the g equation, the x's with 4, then we replace the x with the 4 and we get 2. In the case of f of a plus 1, we replace all of the x's with a plus 1. So we have, this was x squared, this was x. Now you have to FOIL that, getting a squared plus 2a plus 1, and then distribute the -3, bring down the 1, combine like terms. Here, f of 10, okay, we replace the x with 10 and we get a -2. Your answer is undefined, or we could simplify it to square root of 2i, or I square root of 2, but for the sake of this, undefined is an adequate answer. Here we have f minus g and of -8. So we're taking the f equation, okay, and we're replacing all of its values with -8, gives you 64, gives you 24, gives you 1, and then minus the g equation. So we replace the x with 8, and we get 0, okay, because, oh, wait a minute, -8, we get 16. So that's, I need to fix that. Oh. So this would be 4. Okay, now that all equals 85. Okay, on number 6, we're going to multiply these two if x is replaced by 0. So g, if x is replaced by 0, we get square root of 8 for g. And f, we would get, that's 0, we would get 1. Okay, so in this case, we would have our h rather we're looking at. So we would have 2 over, here's my square root of 8, and here's 2 over 0 plus 1 right there. And that would give us 2 square root of 8. 8 breaks down into 4 times 2. Extract 2 out of that, giving us 4 square root of 2. Number 7. In this case, we take h and replace the x with -1. We get an undefined value. In these problems, we have to tell the domain, okay, of whatever it asks for. So if we take r, x squared plus 3, and subtract t, x plus 4, okay, so we have the first one, r minus t. We distribute this negative and then combine like terms. Well, this is a parabola, okay, with the y-intercept of -1. Okay, and the vertex of, or the line of symmetry rather, being, well, let's see, that's a -1, so it would be 1 over 2 times a 1/2. Okay. Now, infinity to infinity here, x can't be 0. Anytime you have a fractional one, for finding the domain, you don't need to be concerned with the numerator. You only need to be concerned with the denominator. Since x cannot be -4, that's an equal sign and a not a plus or minus. Then that gives us these disclaimers with a gap. So it won't be inclusive of 4. So I use the parentheses. Okay, here I'm multiplying these, 2 over x, and x plus 4 gives me 2x plus 8 over x. That could be simplified a little bit, but it's not necessary. The important thing we need to know is x cannot be 0 in this part of this. X can be anything up here, but x can't be 0 down here. So that puts these two limiters right here, can't be 0, so there's a gap at 0. We weren't required to do different quotients. And in this case, we want to compose these. What this statement right here means is we're going to take this g equation, which can be defined as g of x, and we are going to use that as a substitution value into everywhere there's an x in the f equation. In a sense, this is kind of like what we did up here, where we used the a plus 1 as a substitution into every x. It's a very similar process. So here's the x squared, which we've replaced the x, and the x right here, we've replaced that. We simplify this, we have to FOIL that, we get 25x squared plus 40x plus 16. Here we get -15x minus 12, and we bring down the 1. Now we combine all like terms, ending up with 25x squared plus 25x plus 5. Now we're going to reverse this process. So in other words, we're going to take this quadratic formula right here, and then we're going to substitute it into that x in the g equation. Okay, so we're going to take this and substitute it into the g equation. So I've got 5 times x plus 4. okay? Or I should say 5 times f of x. I distribute that 5, combine like terms, and I get 5x squared minus 15x plus 9. Problem number 14. Okay, this time I'm taking g into f. So I'm going to replace the x's with this x squared plus 5, square root of x, square root of 5x plus 5. So in my original equation, I've got 5 times substitution squared minus 1. Well, this square root of 5x plus 5 squared is just 5x plus 5. So now I distribute that 5 out front, getting 25x plus 25 minus 1. And I simplify that to 25x plus 24. I'm reversing order this time. This time, here is my fundamental equation, and I'm going to replace this x with that phrase. So I did that here. I distribute, simplify. I get the square root of 25x squared. 25 is a perfect square, gives you 5. Square root of x squared is just simply at absolute value x. Okay, here we have a rational one, so we've got to look at any values that we can't use. So we can't use positive 4 because that would give us an undefined value. So we do g of 9. Okay, so I take 2 times 9 minus 8, which gives me a value of 10. So g of 9 is equal to 10. So then I replace that 10 sequentially into the f equation right here. Simplify it, and you get 1/2. When we reverse, we're going to reverse the order, and we're going to use a different substitution value. So I replace, here's 3 over x, the replacement, minus 4, okay? And that gives us 3/2 for f of 6. Then I take f of 6 and put it into g of x. So here I replace this x with a 3/2. I simplify, and I get -5. Better leave that there just another moment. Number 16. Okay, we've got we can't we can't use values of -2. So here we've got this. This time we're just going to use values. Excuse me, my allergies are going nuts today. That'll be a lot of fun at the dentist in a little bit. Okay, so anyway, we're going to take the f equation and we're going to replace the x's with the g values here. So I replace this x in the denominator with 3x minus 2. And I start simplifying it. I get 3 over 3x, which I simplify to 1 over x. Now, in this case, I had the value of x equals -2 that I couldn't use. And because of this one, I also have the value X cannot be 0. So this is going to be a three-way here. We go from negative infinity to negative 2, not included. We can't include that. Union with the negative 2 to 0, which is our next stopping point that we can't include. And then 0 to positive infinity. So we actually have two gaps in this equation, one at negative 2 and one at 0. And those gaps, by the way, are called asymptotes. Okay, let's go on. And we could do these, but we're not going to do these because this is asking us to decompose. Okay, estimate the function values from the graph. F minus g of 3. So first thing we do is we look up f of 3. Okay, if f is 3 or x is 3 on the f equation, 1, 2, 3, we go up from here and we see that if x is 3, then y is 4. That's where this 4 came from right here. Now we'll do the same thing with the g equation. If x is 3, then y is 3. So here's that value. So 4 minus 3 is 1 because we're subtracting. Now we're going to do a similar process, dividing when x is negative 2. So we go to the g equation. X is negative 2, 1, 2. And that gives us a value of negative 4 right here. Now we go to the f equation at negative 2, and we get positive 2 right there. Simplify this, and we get the overall answer of negative 2. Question number C. G compose f of 1. Okay. So first thing we do, we find f of 1, and we go up right here, and we see that the y value is positive 2. That's where this 2 came from. Now we're going to replace that 2 into the g graph. Okay, if x is 2, we go up and find we have a value of 4. Okay. I'm barely going to be able to reach this. I may have to jump back and forth. Okay, f compose g of 3. Okay, so we find the g of 3 right here, 1, 2, 3, and go up, and it's 3. And of negative 3. 1, 2, 3, and go down. Okay, which is negative 4. Then we take f of negative 4. 1, 2, 3, 4 on the f equation, then would be negative 2. Okay, on this one, we find f of negative 3. F of 1 to negative 3 is 0. Okay, f of negative 3 is 0. Then we substitute that 0 into the f graph again and see what y is when x is 0. And the answer is 2. Okay, graph quadratics in vertex form. Okay. Now, vertex form is what we've got here. Okay, if it asks for vertex form, this is standard form. Okay. Now, if this A term here or here is positive, greater than 0, then the graph will open up. If that A is negative, then the graph will open downwards. Okay. Now, in vertex form, the H opposite of sign will be two things. One is it will be the X value, okay? This will give you that'll give you the line of symmetry. Now, so in this case, would be like that down through the center. This case, like that down through the center. Now, if you take this value, the opposite of sign, okay, and substitute it into the original equation, then you can get the y value, which this is the y value of the vertex. Now, here's one. A is 1, so it's a non-player. Positive 3, 9, negative 9 is the vertex right down here. That's the line of symmetry. This thing opens up because A is positive. Now it asks, what are the X and Y intercepts? Well, the Y-intercept is if you replace all of the X's with zeros, then what do you get? Okay, you replace this with 0, you get negative 3 squared, which is 9 minus 9 equals 0. Here's the work on that. And so the y-intercept is 0, 0. You can see it in the graph. Now, for the x-intercept, you replace y with 0, or in other words, replace the f of x with 0. So we've got this. Take the 9 on the other side. They didn't show it, but take the square root of both sides, plus or minus, and you get that, which gives you the points 6 and 0 here and here. The y-intercept and the x-intercept are one and the same in this case. Okay, we said the axis of symmetry was here, which is where x is 1, 2, 3. Where did we get that? This value opposite of sign. Okay, problem number 2. This time we have a negative A, so this thing's going to open downwards. The line of symmetry is going to be x equals positive 2. 1, 2, you can see line of symmetry here. Okay. To find the y-intercept, we replace this x with 0, and we get negative 2 squared is 4 times a negative is negative 4 minus 1 gives us negative 5. Okay, right here's the notation on what I just said. So our y-intercept is 0, -5 right here. Now, we can find this point by its 2 places to the line of symmetry, so 2 more places would give us another point right here. Okay? That's easier than doing an XY table. There is no x-intercept on this one because it opens downwards and the vertex is below the x-axis. Now we've got an equation in standard form, and it tells us to put it in vertex form. Well, I've taught you that to find the line of symmetry and the x value on an equation like this, you use -b/2a. Well, that gives us -20/4, which is -5. Okay, so that means the line of symmetry is x equals -5, which is the first value of the vertex. Now we take that -5 and substitute it into the equation, and it gives us -8. So the vertex is -5, -8. Based on that, -5, opposite of sign, bring down this value, and that gives you the vertex form. Now, you noticed here we had a 2 here. So A is 2, and A is 2 on the final form. Okay? Now, in terms of finding the x and y intercepts, the y-intercept is easy. It's 42. To find the x-intercept, we can replace y with 0 and solve this thing. So take the 8 on the other side, divide both sides by 2, and we get 4 equals x plus 5 squared. Square root of our x plus 5 squared. I need to take the square root of this and take the square root of this, plus or minus. So we get plus or minus 2 equals x plus 5, which gives us the value -3 and -7. By the way, there is another way of changing an equation from standard form to vertex form, and it's called one of our factoring methods that we use, and where you find perfect squares on both sides, and it's a pain, and it's not required on this course. Okay, here's another one. In this case, A is -1. Okay. If we use x equals -b/2a, we get x also equals -1. So -1 is the x value of the vertex and also our line of symmetry. We substitute in -1 into the equation, and we get +4 for the y value of the vertex. Because that's negative, this opens downwards. The y-intercept is 0, 3, right over here. So we've got this point, that point by symmetry. Okay. Now, in order to find these 2 points, the x-intercepts, we let y equal 0. Oh, by the way, if this point is the point -1, 4, that gives us the vertex equation, opposite of sign 1 and same sign 4. We replaced y with 0. Okay, solved it, and we got the values of -3 right here and +1. Now, one more thing, it asks us to write the domain and the range. Well, the domain, because these go outward forever, is infinity to infinity. The range, you always start from low to high. So you start at -infinity and you go up to a high point of y equals 4, which also could be called a maximum. This question is a discriminant problem, basically. Okay, you have these three choices, A, B, C over here. To determine the discriminant, you use what goes under the radical on the quadratic equation, b squared minus 4ac. If you put the numbers, the A, the B, and the C into this, if you get a negative answer, then you have no x-intercept. It's going to be imaginary. If you have a positive perfect square answer, then you're going to get two intercepts with a positive and negative. If it's a positive non-perfect answer, non-perfect square answer, then you're also going to get two x-intercepts, but you're going to have radicals in. And if you get 0, then you have exactly one intercept, which will be the negative b over 2a. Okay, find the vertex of the parabola by using the vertex formula. Okay, here's the vertex formula, the first part of it. We've already talked about this, negative b over 2a. That finds the line of symmetry, and it also finds the x value of the vertex. Then you substitute that into the equation to get the y value. Okay, here's the equation. Determine the vertex from the formula. So we take the negative b over 2a, gives us negative 48 over 2 times negative 3. Simplify that and you get positive 8. So x equals 8 is the line of symmetry, and 8 is the x value of the vertex. Now we take that 8 and substitute it into the equation, and we get 27. So our vertex is the point 8, 27. Now, in vertex form, this problem would be negative 3 brought over for the a value, 8 opposite of sign, and 27 in vertex form equation. Here was just a word problem that we actually went over in class. Okay, we're going to determine end behaviors. All of this is math speak on what qualifies. Now, here's the real stuff. If your first term, the x power is even, then both ends will go up or both ends will go down. If a is positive, both ends will go up. If A is negative, both ends will go down. Over here, if the power of the leading term is odd, if A is a positive number, it'll go from low to high, although it may take some bumps in the middle for fifth, seventh, ninth degrees, and so on. If it's an odd power and A is negative, then it'll go from high to low, even though it might have to go through some undulations. Okay, given that information, we look at this equation. A is positive, and it's an odd power. Because it's an odd power, then it's going to go from low to high. In this case, A is negative, and my leading term would be x cubed x fourth. So even. So even, I'm going to have a W either up or down. And in this case, because the A is negative, it'll start down and it'll end down. Zeros and multiplicities. Okay, for when we find zeros, in other words, the x values on a graph, we need to determine whether they're touch and go or whether they're crossing in order to be able to graph them. Now, just to find the zeros itself, then and another root for zeros is roots, okay? We need to factor the equation, or depending on the degree, use long division or synthetic division. We'll talk more about that in a few minutes. In this case, this will factor by grouping. Okay, here's the equation. I group the x cubed and the negative 5x squared, and I factor in x squared out of both of these two. Then this business, I factor 16 goes into 80 exactly 5 times. So I factored a negative 16 out of both of these, and I get negative 16 times x minus 5. Well, you notice I've got x minus 5 both places. So I factor it out, leaving x squared minus 16. X squared minus 16 is a conjugate, so you could get x plus 4, x minus 4. Either way, it'll ultimately come down to the zeros of plus or minus 4. The x minus 5 gives us the 0 of positive 5, always opposite sign. Problem number 4. Okay, now, in this case, here's my equation. These are not A, B, and C constants. What I'm referring to is here I have the first x term, the second x term, the third x term. Now, in this case, this one is going to produce a root of x equals 0 when you use the zero properties rule, okay? This one will produce x equals positive 1. This one's going to produce x equals negative 3. Now let's look at the multiplicities of this. Well, there's a first power hidden behind this x, so it's multiplicity 1 because it's an odd power. There's an even power on this one, so it's multiplicity 2. It's going to be a touch and go. The multiplicity 1 is going to be a crossing. And for the third one, because there's an odd power here, multiplicity 3, then that means that this will also be a crossing 0. Now, what do they have on the graph? 0, multiplicity 1, so it's crossing. 1, multiplicity 1, so it's crossing. -1, -3, I mean, right here, and it's crossing. This is not the same problem we had before. Earlier, we had a second power behind this parentheses, but this is a totally different problem. If that were a +3, then that would have to be a touch and go, and this would become an even with up and up. Okay, problem, this one. Okay, here, we've got a crossing 0 at 0. Here, we've got a touch and go at +1, right here. From this 0, it goes up a little bit, back down, touches, and then goes. And here we at -3, we have a crossing 0 also. You can see our, you can see our ending patterns. Okay, over here, I've got a crossing 0 at 0. I've got a crossing +1. I've got a crossing, no, I've got a touch and go at -3 because I have a total of 2, 3, 4th degree. Then I have to have the up and up or the W shape. Okay, so here I go up and up from these outward points, and you can, how would you get this maximum and that relative minimum there? Well, you'd have to use an XY table. Okay, this is just going over what I just said. If it's an odd multiplicity, it will cross. If it's an even multiplicity, then it will just touch and change directions or touch and go. Okay, there is a rule on turning points. The turning points rule is whatever the degree of the equation. For example, if it's x cubed, then the graph will change directions up and vertically up and down at most 3 minus 1 times or 2 times. So this thing's going up, turns here once, turns there twice. Sketch a polynomial. Okay. First, we look at what leading terms do for us, whether it's like that or whether it's like this or like this. Can't hardly see that in my screen, I'm too close. Then you find the y-intercept, find any real zeros, plot the x and y intercepts. It may or may not, depending on if it's a quadrilateral, find the vertex, and then start the beginning and ending directions, and then fill in the middle. If you have to use XY tables, you can. Okay, so let's sketch this one. Need to raise that up just slightly. Okay. What's our total degree? 2, 3, 4. So this thing's going to be W shaped. Here's our general shape with a 4th degree equation. We're going to have at least, at most, 3 terms. Well, let's look over here. 1, 2, 3. 3 terms. Okay, for our intercepts, okay, if we let x be 0 in all of these, then we'd have -1 squared times 3 times -4. Okay. And that would give us a value of -12. So our y-intercept in this case is -12. Notice our scale here. This is not the same scale up and down as it is sideways. Each one of these squares is 10. Okay. Now, if we want to find what these are, here we've got at +1, we've got a touch and go. At -3, okay, right here, we've got a crossing. And at +4, we also have a crossing. First, we draw these two ending lines. Realize that this is crossing, so we go down a ways, then up to the touch and go point, through the y-intercept point, down to another minimum, and then back up here and upwards bound. Now, how low does this go and how low does this go? You got to do an XY table to figure that out. Okay, number 8. Okay, there's a power there, so I can't hide that. What is my total degree? Well, it's 2, 3. Okay. Now, my leading term is negative. So this means this is going to go from high to low. And at most, we can have 3 minus 1 is 2 terms. So let's find the intercepts. First, let's find the y-intercept. Replace x with 0, you get 1. Replace x with 0, you get -3. You square the -3 times 1 times a negative, and that gives you -9. And so 0, not -9, right here is your y-intercept. Okay. -1 is a 0. +3 is a touch and go 0. So we know we're going to cross here. We know that we're going to touch and go here. We know we got to go through this point. And we know that this thing has to go from high to low. So we start here, we come to the -1 through the y-intercept up to the touch and go point and back down. And with that, that's all we're going to get done today. Okay, it's time to begin. So we'll go ahead and get started. We'll take up where we left off yesterday on going over the whole chapter review. Okay, we were ready to begin on 3.3. Okay, what we had here was we're going to go into long division. This is just simply showing that you can either have a remainder in remainder form or in fractional form. Okay, and it identifies the dividend, divisor, and quotient. So to actually do the long division, we take this, we put it in the box, and then we're going to divide by 2x minus 5. The 2x is our primary estimator. Okay, and with that, Since there are two items here, two levels here, we put our first part of the answer at the second degree column. Okay, so x squared times 2x gives us 2x cubed. Okay, we subtract both of these by changing their signs. So this becomes positive 6x squared. And we end up with negative 6x squared plus 13x we bring down. Our estimate, 2x times negative 3x equals negative 6x squared. So we distribute this 3x and we get negative 6x squared plus 15x. We subtract both and we get negative 2x plus 15 after we bring down the 15. Okay, the estimate again, in this case, negative 1. So we distribute, subtract, and we have a remainder of 10. So our answer on this one then is x squared minus 3x plus 1 plus 10 over 2x plus 5. Okay, on problem number 2, you notice we have a couple of missing terms. We're missing the x cubed and the x squared, so we have to put in 0 terms to hold those places. Okay, in this case, x to the 4th times x gives us x to the 5th. So we distribute. Notice I'm lining up all my x fourths in a straight column. Okay, so I get x fourth times x is x to the 5th minus 3x to the 4th. I subtract, and in this case, I get 0. I bring down the 0, I get 0. I bring down the 0, I get 0. Okay. Finally, I bring down the 12x. Okay. And I also bring down the negative 33. X times 12, x goes into 12x 12 times. So I multiply by 12. I have a remainder of 3. So my answer is x to the 4th plus 12, because we don't have to show these 0 terms, plus x over x minus 3. Problem number 3. Here we have 3 terms. We did not have to put in any 0 terms. So x squared goes into 2x cubed, 2x times. Okay, so we distribute that, subtract, and we get 8x squared minus 24x. We bring down the 32. Okay, to get 8x squared, we take x squared times 8. We distribute, and in this case, we have a 0 remainder. That means that 2x plus 8 is a factor of this problem, of this equation. And it also, in this case, this could be further factored into 2 times x plus 4. Okay. And so basically, this can be 2 times x plus 4 right there, or 2x plus 8. Okay, we're going into synthetic division. Okay, here's our divisor. You notice the minus here because this is a factor, so we have to change to a plus for the 0 or the root. Here are our steps. Put the equation in a box with only the coefficients. Draw the line. And then we're going to bring down the leading coefficient. Okay, we take 8 times 1, which is 8. 13 plus 8 is negative 13 plus 8 is negative 5. We take 8 times negative 5 and get negative 40, which gives us 6. We take 8 times 6 is 48, which gives us a remainder of negative 1. So that brings this equation down to 1x squared minus 5x plus 6 plus remainder of 1 over x minus 8. Okay, another case. We have this one. We've got missing terms for x cubed and x squared. And then we're going to divide by x minus 3. So if the factor is x minus 3, the 0 or root is positive 3. Bring down, multiply, add. Multiply, add, multiply, add, multiply, add, multiply, and remainder 3. So that gives us x to the 4th plus 12. We don't have to show the 0 terms, plus 3 over x minus 3. On number 5, by the way, on this one, because there is a remainder of 3, that means that x minus 3 is not a factor of this, but the point 3, 3 is a point on the graph. Just like back here, well, this still has to be factored more. All right, so let's go on. We're going to divide by negative 10, the 0. They have 2 out of order. We've got to put these in the correct order. These have to be in descending order. Bring down the 3, multiply, add. Multiply, add. Multiply, and a 0. So x plus 10 is a factor of this. And what have we got left? Well, x squared plus x plus, 3x squared minus 5x plus 2 is what this divides down into. So what that's saying is that this value times x plus 10 equals this value up here. Okay, I've kind of introduced you to this already. Okay, what this is saying is if you have a remainder, then if x in this case is negative 1, then y is also negative 1. So the point 1, negative 1 is a point on the graph. That's what that's saying. Okay, you can always take this divisor and any remainder, and that will be on a point on the graph of this particular equation. That's the remainder rule or remainder theorem. Okay, number 5, square root of 5 is our root that we're going to test. Bring down, multiply, bring down, or add, multiply, add the real numbers. Negative 5 and 5 make 0, so I just got the radical part of it left. Multiply, and I get negative 20. Okay. In other words, negative 4 times square root of 5 squared. I get negative 20, 0 remainder. So what that's saying is that this square root of 5 is a 0 of this. And if that's true, then negative square root of 5 also is a 0. because radicals have to come in conjugate pairs. Number 8, they're telling us to attempt to test 8i. Now, knowing to try that 8i is not something that we're doing in this course. But in this case, they're telling you just to get you where you can actually deal with this. Okay, so bring down, multiply, and we get this, 1 plus that. Multiply by distribution. We subtract the real numbers, leaving 8i. Multiply, negative I squared, we get 64i squared, and I squared is equal to -1, so -64, and a 0 remainder. Therefore, 8i is a 0. Also, -8i is a 0. In this case, those two factors would be written as x minus 8i x plus 8i. It's supposed to be an 8. Okay, over here, first we check, do we have any missing terms? No. And they're checking to see if x plus 4 is a factor. Well, we go through this, bring down, multiply, add. Multiply, add, multiply, add, 0 remainder. So x plus 4 is a factor of this thing, okay? So what that means that so far factor-wise is we have 6x squared minus 13x minus 8 times x plus 4. Okay, equals f of x or 0. Okay. Now, if we had to continue, then we could try to break down this. We could factor it if we could. We could attempt some of the multiples of 8 and 6, or we could just more easily use the quadratic formula to get the final roots from this part of this thing. But what we do know is that x plus 4 is a factor of that, and -4 is a 0 of that. Okay, in this case, we check to see if we have any missing degrees. The answer is no. We're going to test x minus 6 to be a factor. Okay, well, that means we're going to try positive 6. Bring down, multiply, add. Multiply, add, multiply, add, multiply, add, multiply, 0 remainder. That means then that yes, x minus 6 is a factor and positive 6 is a 0. So far we've factored this thing down into x minus 6 times this 4x squared, no cube term, minus 3x squared, no x term, minus 1. Now, 4x to the 4th minus 3x minus 1 factors into 4x squared plus 1 and x squared minus 1. Okay? X squared minus 1 further factors into x minus 1, x plus 1. Then to get the value here as a factor, we can't break that down anymore. But if we need the roots, though, here we have positive 6. Here we have positive 1 and negative 1. And then finally, this using the square root property, we take the square root of both sides plus or minus. We get 2x equals plus or minus 1. So x equals plus, because that's a negative, that isn't a 1. 2x equals plus or minus I. And now we divide both sides by 2. So x equals plus or minus 1/2 I. Okay, this is just the opposite. Now we're starting with factors and we're trying to get the final equation. So this process is just the opposite of what we were going to do. So now we're going to multiply it out by distribution or by the foiling or something like that. This one, if we take x minus 2 and square it, we get x squared minus 4x plus 4. We bring down the x plus 5. Now we distribute this x, we get this row. We distribute the 5, we get this row, lining up the powers. Then we combine all terms. And this is the equation that we get. Notice on here, it had said we had a 0 of 2, which meant we had a factor of x minus 2 of multiplicity 2. Okay. And we had a factor of, or a root of -5, which gave us the factor of x plus 5. So that's where we got these two terms. Now we'll go to 3.4. This time, remember we look at the n term, okay? The n term and the leading term. So we take the factors of the n term over the leading term, simplify them, and that'll be all of the rational zeros, not all the reals, because square roots are still real, but this will be all of the rationals up through fractions. Okay, so given this equation, based on the -15, we got the plus or minus 1, 3, 5, and 15. Okay, what they've done is they've shown the pairs, 1 and 15, 3 and 5. Here they're showing 1 and 4 and 2 and 2. But I usually put them in increasing order. If I see a 4, I say, okay, 1 is a factor, 2 is a factor, then 4 is a factor. That's just the way I usually do it. Okay, so what are all the possible factors? Well, we've got all of these, and then we have the 1 divided by the 4, the 1 divided by the 2. We got the 15 divided by 4 and 2. And we got the 3 divided by 4 and 2. And finally, we've got the 5 divided by the 4 and the 2. Okay, so that's all of your possibilities. You will have a problem on the test like this, where I give you an equation, and then you just have to list all of these possibilities for me. Okay, here's another one. Actually, this time you have to find possibilities and then you have to try to use them and to break down this equations because it says find the zeros. Okay, so we're going to try the simplest one of these first. So we're going to try positive 1, and it comes out a 0 remainder. So that means x minus 1 is indeed a factor of this problem. Well, we're going to try a 1 again, because you can have 1 multiplied to it times itself multiple times. We try it again, and we get a 0 remainder again. So that means we have a multiplicity 2 of the factor x minus 1. Now, what do we got left here? We got 2x squared plus 5x plus 3. Okay. Now, 2x squared plus 5x plus 3 breaks down factors into 2x plus 3 and x plus 1. So here's the complete factorization of it. So we have factors of positive 1, multiplicity 2, because there are a pair of them. Take this 3 on the other side, divide by 2, we get negative 3 halves. And it has a multiplicity of 1. Take the 1 on the other side, we have a negative 1. Okay, so these are all of the factors of that problem. Now, how many factors do we have? 1, 2, 3, 4. What degree was this equation? 4. Okay, find the zeros and their multiplicities. Here are the, excuse me, here are the possible factors. I'm going to attempt 5, positive 5, a factor of x minus 5, and I get a 0. So x equals 5 is a 0, and x minus 5 is a factor. Okay. Then we would have to factor this thing. Factor or use the quadratic formula. They chose to use the quadratic formula. And it's a good thing they did because it came out radicals. Negative 3 plus or minus square root of 5 all over 2. Okay. So your zeros are these, a plus or minus pair, and then also x minus 5. Excuse me, x equals 5. Okay, we use the fundamental theorem of algebra, but we're not going to go through the technical language of it right now. So let's go through these. Okay. Now, this time it's saying 1 minus 5i is a 0. Now, what that means is that they are saying that x minus 1 minus 5i. Uh-oh, that's not cool. Parentheses, brackets. That's saying that this thing looks like that as a factor. Now, if 1 minus 5i is a 0, then 1 plus 5i also. a 0. And it in turn, I'll show you what it looks like in a little bit. Okay, so we do this division, comes out with a 0 remainder. That tells us that yes, it is a factor. Now they tried the 1 plus 5i. Like I said up here, if you've got 1 minus 5i, you have to have its conjugate 1 plus 5i. So we did the division. We got a 0 also, leaving the factor x minus 1. Well, the factor x minus 1 produces a 0 of 1. So we have these 3 factors, 2 imaginary factors and 1 real factor in this case. Okay. So this is just some of their scratch work for in the middle of this thing. In factored form, then I use brackets instead of parentheses on these, but that's okay. The 1 minus 5, x minus quantity 1 minus 5i, and x minus quantity 1 plus 5i, and then the x minus 1. Okay, so here would be your answers. All they did between this step and this step is they got rid of the parentheses. Okay. Okay, given that x equals 1/2 is the solution of this, this is telling you that 1/2, negative 1/2, is a solution. What that means is when we divide it, we should expect it to be a 0 remainder. So we do that, and in the process of doing that, then we are able to find out here, we go from x to the 4th minus x cubed plus x squared and so on. We step down 1 degree to 2x cubed minus 2x squared plus 18x minus 18. Now, we're just going to try, based on these, we're going to try positive 1. It might have been right, it might not have been right. In this case, because we came up with a 0 remainder, it was correct. Well, what does that leave us? That leaves us 2x squared plus 18. So far we've got these 2 values. We can take this, divide both sides, every term by 2 is what they did here. Now they take the 9 over to the other side. Okay. In this case, they had x squared equals negative 9. They took the square root of both sides, plus or minus. The minus gives us the I, the 9 gives us the 3, and we have the plus or minus. Okay. Find the lowest degree with zeros of 3i and 2, multiplicity 2. Well, if there's a 3i, there's a negative 3i, it's conjugate. So x minus 3i, x plus 3i, x minus 2 quantity squared. Then it's a matter of multiplying these out. These 2 give you x squared plus 9. This one times itself gives you x squared minus 4x plus 4. And we get that. Okay. Now, we don't know in this case if there is a multiple out in front of everything, okay, because they don't show us the leading term constant. Now, in this case, they have to tell us that the y-intercept, where x equals 0, then y equals 32. So this is the y-intercept. They tell us it has to be 32 when we're done. So let's see what we've got. We know this thing's got to be a cubic when we're done. We know that negative 2i and positive 2i are factors, and 4 is a factor. So here's our negative 2i, here's our positive 2i, and here's our positive 4. We multiply those out, and we get this thing. Okay? Now, if the n term has to be 32, what do we have to do to A to make this n term 32? Well, we have to multiply it by negative 2. Okay? And if we multiply that by negative 2, in other words, if A is negative 2, then we have to multiply every one of these terms by negative 2, which is what I'm showing down here. Now, here's the process. We take this equation. In this case, it's pretty obvious. If we got to have 32 here, I mean, it's pretty obvious on this one. We need to multiply it by negative 2. But if it's not so obvious, then what we do is we let, okay, when it's 32, x is 0. So we let this be 0. We let that be 0. We let that be 0. Leaves us this. So 32 equals negative 16a. Then divide both sides by a negative 16 and you get negative 2. That's how you do that. Well, anyway, here is your final answer. Now, what do? We take the zeros they give us, change them to factors. We multiply it out, adjust for A if we have to. And we don't have to on every single problem. Okay, now in section 3.6, we went into inequalities. Okay, so we've got the 4 inequalities. Now, let's look at this one. Okay, first thing we want to do is we want to multiply this out and move the 15 over to the other side so it looks like this. Then we can factor that and get zeros of 5 and negative 3. Here and here. Now, at this point, we take this equation and put this less than or equal back into it. So in other words, so we have x squared minus 2x minus 15 is less than or equal to 0. That's what this curve is, or that's what the curve is, this with the equal. Now, what we're going to ask is what is the range of the domain in this problem? That's what this problem is asking. Okay? So what we do is we look at this point and we look at this point. Because it's or equal, those points, the 5 and the negative 3, are included. And this graph, everything between 5 and negative 3 on the graph is below the x-axis. So the answer then to this equation is the domain of -3 to +5 inclusive. Okay, let's look at this one. Here they give us an equation in factored form. That gives us a value here of -3, right there. It gives us a value of +2 right here of multiplicity 2. Okay, this multiplicity 2 means that's a touch and go spot. This is a crossing spot. Now, the question is where is this above 0? Not or on equal 0, but above 0. It starts getting above 0 here at -3, but the -3 is not included because there's no or equal. It stays above all the way to 2, but the 2 is not as included because it's on the 0 line. And we union that with start at 2, not on the line, and everything above. So in other words, these are the ranges of X values that are above, greater than, X equals 0. Okay. In this case, here it is. Here's our graph. Okay. Now, in this case, there's only one point because this says less than or equal. It touches this point at 5/2. The 5/2 is included simply because the or equal. Okay. Or in other words, in this case, that one point because of that or equal. Okay, this one, it's the same problem, only they've changed the sign to less than or equal to less than 0. In this case, since you can no longer include that, then you can't have it, so there is no solution because there's nowhere is this graph below the line. This one says above or including. Well, in this case, all of this is either above or included. Okay, we didn't have to do the rationals. Okay, and that leaves us with this. And this is basically what we went over day before yesterday. So I'm not going to go through these. I'll go through these here. Let's write the equation of variation. Well, the speed is a constant times how hungry he is times how big the cheese is. Varies jointly as X. So Z equals KY. Or XY, KXY, easy for me to say, inversely as square root of P. Then on problems like this, and you will have problems like this on the test, where it gives you, you set up the initial equation, you solve it for K, you rewrite the equation with the K value, and then they give you new values to substitute in, and you solve for a variable. And that's basically the chapter.